Let's see if we can do a little something. All right, so let's look at this. So now these are the things to consider when you are making a comparison of histograms. Okay? So part of this course is to get you to critically look at data. So critically, you are looking at all of the characteristics. So here, we are going to look for, check for shape, check for the maximum and minimum terms, estimate the median, and that only applies to the histogram because the median is clearly marked in the box plot, and look for any outliers. And remember, outliers are just those values that lie outside of the main body of data. So if we look at the histogram first, right? So we see the shape, low end, most of the data has been pushed to the left, right? So for histogram, we know what shape is that. Somebody? Just looking at the histogram. What's the shape? Left skewed, right skewed, or symmetric? And I can't see the chat when I'm sharing my screen. Let me see. No, I can't see the chat. So if anybody's responding, can you just say it verbally, please? Again, if we connected just the tips, these corners of the graph, starting here, right? So we would go here, that's separate. So this is the main body. So we start here, hit the corners, it goes up here, that's the top, and here's where it would take its turn. Okay? So shape first. Then we look minimum and maximum of the data. Because again, remember, you will only, in your box plot, will only be graphing, or will only show 0 to 12. Because this is considered an outlier. It lies outside of the main body of data. So our minimum value will be 0. Our maximum value will be 12. When you estimate the median looking at a histogram, remember, the median does what to the data? And again, I can't see you typing, so if anybody is brave enough, please respond. The median does what to the data? Well, where is the median in a data set?
It's usually in the middle.
In the middle. Exactly. So anything in the middle splits the data 50-50. So now, here, if we look for the median in this histogram, we are trying to get to half. We are trying to get to 50. So when we look 0 to 2, because also when you look at this histogram, the histogram marks the years in multiples of 5. However, ladies and gentlemen, they are moving by 2s. So this is 0, then it's 2, 4, 6. Halfway between 4 and 6 is 5. So this is 6, 8, 10, 12. Okay? So first you had to figure out the scale that they were using. But again, back to the median. So if the median splits the data in half, that means 50-50. The median, to figure out where the median would fall using the histogram, they gave you these numbers up top. Use them. Okay? So we are trying to get to 50. Right? So this first bar between 0 and 2, we already have 40. So if we are trying to figure out the median, we want 50. We have 40. So that means that we're going to have to take 10 out of this interval between 2 and 4 to get to the median. So that means the median of our data set is going to fall between 2 and 4. Did that make sense? Because that might help some of you also with the first checkpoint. Okay? So again, the median means you have split the data 50-50. So when you are looking at a histogram and you are trying to figure where the median is, you might not, or what interval the median falls in. You won't be able to speak to a specific number because we know in a histogram, because things are grouped, that takes away our ability to talk about individual terms, but we can talk about the group. So again, for this histogram, the median is 50 is at 50. We have 40 in this first tower. In the first bar, we will borrow 10 of this 28. So that means that the median falls between 2 and 4. So look at the box plot. Same thing. The median, the darker line, falls between 2 and 4. Yes? We look for outliers. Now, again, an outlier is anything that is not a part of the main body of data. And it is marked in a box plot. See this little circle out here? That circle, excuse me, is representing this value. So when we look at the 2, the minimum is 0, the maximum is 12. Again, started here at 0, ended here at 12, the main body. The median falls between 2 and 4. We just discussed how we will use everything from 0 to 2, and we only need 10 in the interval between 2 and 4. So the median falls between 2 and 4. Okay? And then we draw the whiskers. Make sense? And this is right skewed. Okay, because right skewed means that the right or upper whisker is longer than the left or lower whisker, and the Q2 value, the median of the data set, is closer to the median of the lower end of the data. We're going to critically analyze what we see. Now, the second one, when we look for those same 4 things, again, shape, we starting low, we going high. So we know it's skewed. And again, the tail being on the right side means that we know it's skewed right. We check max and mins, minimum, 0. Again, when we look at the scale, what's the scale? How are they moving? Because that's 50,000 where the cursor is. What's the values here? Can anybody think of what they could possibly be? How they're moving? All right, that's okay. Because again, when we look at the cool downs, it'll all come together.
Listen, I ain't gonna lie. This whole Instagram bull crap really confuses me. Like
Say it again.
explain it. You can explain it a million times, and I can look at it. I mean, I'm still not gonna get it.
Real.
Yes, you are. Watch. I'm telling you, you are. You are. So again, so here is the
Like I get the box plot, like the
Okay.
Instagram crap. I can't get it.
Yes, you can. All right. Again, don't say you can't. It's going to come together. So here, ladies and gentlemen, here is the body of the data. So here is the body of the data. And I chose this slide because I wanted you to see, this is how they mark outliers. Most times you will see outliers marked with little circles, but sometimes they will also have an X. Okay. So either way, those are the outliers. So this graph would be described as skewed right with outliers. So most of the data lies here. And then we had these values sitting out here, 100,000. That's probably 140,000. That's probably 160,000 because they are moving by 10,000, 10,000, 20,000, 30,000, 40,000, 50,000. Okay. So let's look at this, Quay, to help you out. Now, this is similar to your cool down. The only difference is your box plots are vertical versus horizontal. So now remember, this would be left side, this would be right side. Okay? So now, when we look at this histogram in A, left skewed, right skewed, or symmetric? Somebody? Anybody?
My fault.
For A, would you describe it as left skewed, right skewed, or symmetric?
This right. This right.
Okay, so this is right skewed. So that means that when we look for the matching histogram, we just said that if it is right skewed, the upper or right whisker is longer than the left or lower whisker. So from that description, which is the mate of histogram A? 1, 2, 3, or 4? Again, well, listen. If it is right skewed, that means the upper or right whisker is longer than the lower or left whisker. And Q2 is closer to Q1. The median of the data set, which is inside of the box, is closer to the median of the lower end. So it is closer to the left quartile marker versus the right.
So would it be 4?
Yep. So A is 4. So that's why I asked you to make sure that you had that little visual summary, because again, it tells you what you need to look for. So now let's look at B. Is B left skewed, right skewed, or symmetric? Nobody? Nothing? Is the tail on the left side of the data or the right side of the data? The tail matches the skew.
The second one got an outlier, so it would be 2.
Absolutely. Yes. Critically examine the graph.
Explain it a million times. So I can get it.
All right. No, but you getting it because you just said that. So ladies and gentlemen, the key to this one was you got this outlier right here. So look for the outlier, critically analyze. And so like she said, it has an outlier. So B is 2. So now 4 and 2 are off the board. So look at C. Left skewed, right skewed, or symmetric? Again, look for the tail. Look for the tail. The tail tells you the skew.
It gotta be 1 or 3.
Yep, it's 1 or 3.
Hold on, let me get my mathematical bag real quick. Hold on.
I love it.
I think it's 3. No, I'm lying. I think it's 1.
Oh.
And
If it is left skewed, the lower or left whisker is longer than the upper or right whisker, and Q2 is closer to Q3. So yes, the median of the data is closer to the median of the upper quartile marker. So yep, C is 1, and then that only leaves 3 to match with D. So D is symmetric. If we split this graph down the middle, left side looks like right side.
Who trying to follow me?
We would look for the same construct in the box plot. The whiskers are about the same length, and the median of the data set, the upper end and lower end look to be about the same. So, yep. Okay. So that was your task for that second cool down. Okay. Let me see what time it is. Okay. All right, that's good. Okay, so now the third cool down. We're gonna go back to the second, but this is the assignment. The third cool down, I was gonna have it due today, but I'm gonna push it till Tuesday. So in Summit, for your third cool down, for those of you who have already done the second, you are going to determine which measure of center should be used with the 3 graphs that you are given. Remember, the mode is that which appears most often. The median simply splits the data into 2 parts, 50-50. And as you see, the left side does not necessarily have to look like the right side. So we are going to concentrate on just splitting it 50-50 when we talk about the median. We are not going to look to see that the left side looks like the right side, okay? So mean, mode, or median, and you know the mean is the average. So for the third cool down, you are going to decide, given those 3 graphs, which is the best measure of center to use. Okay? So now, let's look at the cool downs. I'm going to go. Boom. I want you all, everybody who did not do checkpoint 2 yet, everybody open a new tab, open checkpoint 2, histogram match. Let me know when you get there. And I am still going to have lab this afternoon. So you could, you still, if it doesn't come clear now, you'll have I'll see you this afternoon. All right, we ready to talk about it? All right. Oh, I can see the chat now. So everybody ready? Nobody responded no in the chat. All right, let's do it. What is your first graph? Because they tell me that mine is lined up differently. So what's your first graph? Your first histogram? What letter? Somebody talk to me. Talk to me. All right. Well, I see E. I'm gonna go on what I see. Y'all not talking to me. All right. So in E,
same graph.
You see E?
Yeah.
Okay. So let's look at E again. Critically analyze. So when we look at graph E, just looking at the graph itself, we see that there's some data happening between 50 in the 50s, right? We see the graph, the body of the graph itself is in the 60s and the 70s, and we see that it's some data happening in the 80s. So we see 3 happening in the 50s, the main body in the 60s and 70s, and we see 3 outliers in the 80s, right? So we looking 3 outliers out front in the 50s. We're looking for the body of the graph. So this will be the histogram. And then we have these outliers here in the 80s. Let's slide down to the box plots. Oh. So when we go down to the box plots, we are looking for 3 outliers in the 50s. We are looking for the box plot to happen in the 60s and 70s. And then we have 3 outliers in the 80s.
Is the first one IV, right?
IV, yes. 4 Roman numerals. Yes. Okay, makes sense? Again, critically analyze what we see. That is your task for the histogram. Use the scales that they give you. So, same thing. Now, what's your next graph? Is your next graph the letter C as in Charlie? It is?
No, mine's B.
Okay, so let's look at B. So now, when you look at B, again, we see the scale. The scale goes from 40 to 75, right? Or maybe 39, because it's a little line in front of 40. So let's say it goes from 39 to 75. So that's the first thing. And now let's look at the graph. We have 3 outliers happening down there, 30s up to 45. We got an outlier happening at, like, let's say somewhere between 50 and 55. We have another outlier happening between 55 and 60. And then we have the body of the data happening between 65 and 70. So we should have 5 outliers out front and then your box plot. So let's slide down to the bottom. Again, you got 5 outliers out front, and then you have the body of data. So looking at the box plots, which one matches histogram B? And you all, okay? So that is what, good morning. Who just joined? Hi, Beth. Okay. Bev, what we are doing is we are going over the cool down 2. We are just discussing, and I'm trying to help you all understand what was expected. You were expected to critically analyze the histograms and then match them to their corresponding box plot. Okay? So everybody, you chose whatever you're going to choose for B. So we did the first one together, Beth. We did E together. And we found that E matched box plot 4. Yes, 4. And remember, they are Roman numerals. So that's IV. All right, so that was B. What is your third histogram? What
Hey,
letter?
what you say was B was again?
I don't know. I didn't say what B was. I said for B. You
Oh,
are looking for the box plot that has 5 outliers in front of the box plot. You should have some outliers somewhere between 39 and 45. You should have an outlier somewhere between 50 and 55. Another outlier between 55 and 60. And then you should have the box plot, because that is where the body of your data is. You should have a box plot between 65 and 75. I don't know which one that is, but I will discuss the histogram and you will choose the box plot. Okay? So that was for B. What's next? What's your next histogram? Third. What's the next histogram? We did E, we did B. Somebody's texting me. You love yourself. You don't need nobody else. So you all are good? Now you understand what your task was for the second cool down? Critically analyze the histograms and match them to the box plots. Now, you will see there are 7 histograms, but there are 8 box plots. So you know one of your box plots you are not going to use. Okay? And everybody has their own. There are no repetitions. So do we need any more discussion on this, or now, or do you understand what was required? Oh, wait, I see somebody might be chatting me. I'm sorry. Oh, talking about some hey girl. Okay, we all right with this? Okay. Then I will look at the third checkpoint. For those of you who have done good morning. And for those of you who have done the second cool down, I'm just going to show you the third. And those of you who are still working on checkpoint 2, you can continue. You can just listen. The third checkpoint, it says, for each distribution below, answer the question, which measure of center should I use to best communicate the data? They give you 3. And they even classify the shape. They tell you the shape of the distribution. So the first one is symmetric. The second one is skewed left. The third one is skewed right. They, in the diagrams, they mark the mean as well as the median. And it is your job to determine which is the best measure of center. The mean or the median. That is all. You probably cannot write in those boxes to the right of the diagrams. So put it at the bottom. Okay. Complete sentences. Okay. The best measure of center is. Okay. So that's it for the third checkpoint. Now, if you took good notes, or you go back to those early days of our class and listen to the video, it'll help you out, because this is a repeat of something that we've already discussed about what is the best measure of center, depending on the distribution. All right. Wait, I see somebody chatting, man. All right. I am going to go back to I'm gonna go back to the cool down. Okay. I'm gonna go back to cool down 2. So I'm just gonna go from my screen, because my other class told me that the way my screen or the way my graphs line up was not how her graphs were lining up. So okay, I'm gonna just go by what I see. And I know we've already done 2 of them. All right, people who still working on histogram match, I'm getting ready to talk to you some more. All right, so we have done E, we have done B. I am looking at graph C, as in Charlie. Now, when you look at C, again, first things first, always look at the grid down the bottom. Okay, so we see that this graph is going to go between, like, let's say 47 and 67 for the main body of data. So all right, so when we look at the graph for the histogram C, so like I said, we see the body of data happening like 47 to 67, And then we have two outliers. We have two outliers, and one of them is happening around 71, and the other one is happening around 78. So when you go to your box plots, look for the outliers first. They're easiest. So you should have a body, you should have the box plot, and then I'm sorry, I thought I pushed return. Okay, I need to shift my screen. Okay, sorry. So when you go to your box plots, again, look for the outliers first. They stand out. So you should have two outliers. Like I said, one happening somewhere around 71, 72, and the other one happening around 77, 78, 79, somewhere up there. Okay? And then you should have your box plot, because again, the box plot graphs the main body of data. Your box plot should be happening somewhere between 47 and 67. All right, so we did C, we did B, and we discussed D. Okay. Oh, and we did E. So we did 4? Yeah, okay. So, everybody ready to move on from graph C? So we did E, C, B. Did we do D? Did I discuss D? If I didn't, I'm sorry. I didn't check it off when I did it. So I'm gonna discuss.
No, you did not, Hicks. No, you didn't.
Oh, okay. All right. Thank you. Clay, you don't have to talk to me like that. That was a little aggressive, and you know I'm sensitive. All right. So let's look at D. So for D, let's look for the outliers first. So now, for our outliers, we have an outlier happening around 70. We have an outlier happening around 80, around 85, and 95. So let's look for the outliers first. Think about the grid. So again, remember, we going from, let's say we going from maybe 35 to 95. And again, we have outliers at 70, 80, 85, and 95. So it's only one that I see that falls in that category. So slide down and see what matches D. All right, let's look at, I have F next. F as in Frank. Okay, so now, again, for F, we see the grid across the bottom. We know we working from 45 to 85. That's first. Now, let's look for the outliers. They sit out. Let's see what we got. So we have an outlier just on the other side of 70. So we have an outlier that's a little more than 70. We have an outlier between 75 and 80. We have an outlier at 80, and then we have an outlier that's like 85, 86. So let's look for the grid first. 45 to 85, and we have 4 outliers between 70 and 85. So 4 outliers between 70 and 85. And the grid runs from 45, 46 maybe. Okay, so anybody see anything? This one is a little hard because even for me, they counted 2 things as outliers that I didn't. I considered them as a main part of the body, but that is not how Summit saw it. So again, go with your best guess for F, because we only had 2 minutes. Then I gotta let you go to your next class. All right, so